So today we're going to look at the derivative. The derivative, by definition, is the slope of the graph at a particular point. So yesterday we were using instantaneous velocity was the slope of the line tangent to any point on a graph, correct? And that changed as you changed the point on the graph. Same thing here, your derivative. This derivative helps us provide a general formula for slope of that tangent line. So no matter where we're at on our graph, we can use the same general formula for slope, which is m, and we just plug in our new x value for that point, and we'll end up getting our slope. So that's really what we're concentrating on today. Based upon our discussions with Newton and Leibniz yesterday, we have several different symbols for a derivative. And these are all split into by the equal signs here. So these two forms of notation, they all mean find the derivative of the particular function. These two come from Newton, right here. That's his notation. And then these two come from Leibniz, and that's his notation. They all mean the same thing. And you can see on this one why we no longer like to use d for distance, because d now denotes a notation form for derivative. So you need to become familiar with all of these so that if you come across them, that you understand that they're asking you to find the derivative. So as we look at example 4, I'm going to make mine really big because you're going to have to write really small, and I want to be able to fit it all in here. So the notation here says f of x is asking you to find the derivative of this function. So here's our function. I'm going to help get you started. We're going to use, we're going to kind of tag on our theory of instantaneous velocity and limits and use that to find the derivative. But for this one, f prime of x, which again is asking you for the derivative, we're going to use the following general form. Hold on, I need to get my limit in there. I love to forget that. So it's the limit as h approaches 0 of, let me get my bracelet off so it doesn't create issues, of f of x plus h minus f of x all over h. Oh, let's have a little fun today. How about a purple lightsaber? So this right here is what we're going to use with our function here. So this whole thing here is our function, and everywhere you see an x, you're going to substitute in originally x plus h. So this is just saying take the function, and wherever you see an x, you're going to substitute in x plus h. Then you have to subtract the entire original function. So it's very similar to what we were doing yesterday, but it's all over just the letter h. So this was derived for you by much smarter people than you or I. We could derive it, but I don't really see a point for this course for you. So we're going to use this to find our derivative given a function every time. It's not going to change. So let's go ahead and run through this. So we've got equals, you're going to have to write small, the limit as h approaches 0 of, now we're going to start with our substituting in, I'm losing my voice, x plus h into the function. So we have 4 parentheses x plus h in parentheses squared plus 6 sorry, parentheses x plus h and parentheses, and don't forget that plus 3. So far we've only taken, this is only the original function with x plus h substituted in every time we saw an x. So that represents this part right here. Is everybody clear as to where we got this? We have yet to do the minus f of x. So that comes next. And you have to subtract this whole entire original function in parentheses. If you don't use parentheses, then you're going to end up getting the wrong signs. Bless you. And then all of this, don't drop this off, it's a common error. All of this is over h. So again, here's your f of x plus h, right here, all the way to here. And then this is minus f of x, and that's all over h. So all I did was follow this. So any questions as to where I got that? That's the most important step. The rest is just math. This is going to be your biggest error right here, this x plus h. So you can see over on the board, to the left on the board, that I went and I took x plus h squared and I squared it correctly. It is not x squared plus h squared. Again, another common error. So you're going to get used to squaring the x plus h, and so I would imagine you wouldn't have to go through that work every time, that you could just do the following. 4 times x plus h is x squared plus 2xh plus h squared. It has a middle term. What's wrong? You good? Yeah. Okay. Then we're going to distribute the 6 into the parentheses, and don't forget to add the plus 3. So then we have plus 6x plus 6h, and then plus the 3. Then, so we distributed this 6 into there. Then we're going to take this negative and distribute it all the way into the parentheses. So every single term has to change signs. So we end up with a minus 4x squared, a minus 6x, and a minus 3. All over h. How exciting was that? What's left now? Distribute your 4 into all those parentheses. And so we get equals the limit, and yes, you have to keep writing the limit down, as h approaches 0, of 4x squared plus 8xh plus 4h squared plus the 6x plus the 6h plus the 3 minus 4x squared minus 6x minus 3, all over h. Wasn't that fun? Now here's where the real fun begins. So keep these little self-check things in mind. So you get all of these terms here, and you can see that there's definitely room for error, right? Anything that does not have an h, like the 4x squared, anything that does not have an h, they all should cancel out with something, including constants. And you'll see why in a minute. So this 4x squared doesn't have a negative 4x squared attached to it, so those cancel out. And then I've got the 6x. The 6x is going to cancel with a negative 6x. So those cancel out. And then I have the 3 doesn't have an h associated with it. So it's got a minus 3 over here, that those should cancel out. And then all I'm left with is this 8x to the h, the 4h squared, the 6h, and that's it, right? What do they all have in common? What's your denominator? An h. So no matter what they have in common, if I were you, I would only factor out the h, because your goal, just like our goal was yesterday, is for that h to cancel out. But if you make a mistake and not all of these have an h in common, so let's just say that this was just an 8x. You cannot cancel the h out of these two if that doesn't have an h in common. And that's why I'm forcing you not to cancel here now, but I'm forcing you to factor an h out of them. So you get in that habit of realizing that you can't just cancel when there's addition unless all of them have the same thing in common. So we have the limits as h approaches 0 of h times, I'm going to factor that out of each of those terms, 8x plus 4h plus 6, all divided by h. And so now the h's cancel, and we have the limit as h approaches 0 of the simplified limit. So we've got 8x plus 4h plus 6. Almost done. We have one last step. So very similar to what we did yesterday, we're going to take this 0 right here, and we're going to plug it in for any h that we see. Well, we only have one h here. So you should not have any h terms left over in your final answer. And so our final answer is f prime of x, that's your derivative, is equal to 8x, whoops, wasn't even close to an x, 8x plus 4 times 0 plus 6. So f prime of x is equal to 8x plus 6. That is the equation, the general equation for the slope of any tangent line to that function. It's a general equation to find the slope at any point on that function for that tangent line. So now if I start giving you points on this function, we can find the slope of that tangent line, the exact slope. What if your x value was 1 in this function? The x value point was 1. What would your slope be here? 14. So at 1, whatever, if you plug in 1 here, you get 4, plus 6 is 10, plus 13. So that'd be 113. So at the point 113, the slope of the line tangent to that point is going to be 14. And so I can do that all day long. And so now finding that slope is so much quicker than what we did yesterday, right? So the derivative helps shorten up our work, believe it or not. There's actually a shortcut to this, but you're not allowed to know it yet. I know that's really exciting for you and annoying at the same time. It's important that you understand the skill for some other problems in calculus. Was there any questions on that before we move on to this one? You understood everything?
Are all of them like that long?
No. You'll do one here in a minute by yourself that's not that long.
Where is the H from?
The H comes from the original, this original that I've given you. So because the H is down here and the H is right here.
Is that always given?
Yep. Well, no, you have to know it. So if I say find the derivatives by using limits, you got to know this. And you're going to do it so often that you're going to have it memorized because you're going to write this down every time you do a problem. And so the more you write it down, the more likely you are to memorize it. Does that make sense?
Yeah.
Courtney?
Is the H always going to be approaching 0?
Yes. Any other questions? Okay, so let's move on to B. B is a little bit more difficult because of the fact that x is to the 4th power. And what are we going to end up replacing x with? X plus h. So that's a binomial raised to the 4th power. Don't we know how to raise a binomial to the 4th power? How? Pascal's triangle. So, here we go. I'm going to choose a much prettier color. Let's go with purple. So f prime of x just means we're finding the derivative. And then we're going to use the limit as h approaches 0 of f of x plus h minus f of x all over h. So again, that's the same. It's not going to change. So this is telling us we're going to take the original function and plug in to each of those x's the x plus h, and then we're going to subtract that whole original function and then just put it all over h. So here we go. I don't want to put the f prime of x again. So equals the limit as h approaches 0 of 3 parentheses x plus h. In parentheses, we're raising that to the 4th power, plus 2 parentheses x plus h, in parentheses. So isn't that the function with x plus h subbed in? Then, don't forget, you have to subtract the original function, all in parentheses. So minus the 3x to the 4th, plus 2x. All of that is over h. So the only difficult part here is going to be taking that x plus h to the 4th. So let's go ahead and do that. The limit as h approaches 0 of 3 times. And so how many blanks do I need when I'm raising this to the 4th power? 5. So I've got, and I'm going to put my blanks in black. So I've got 1, 2, 3, 4, 5. And then in between my blanks, because I have a plus sign in here, all of these have pluses. So this is plus, 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 plus. And then I should have end parentheses here. What is the fourth row of Pascal's triangle? 1. 4 is always going to be the second one, right? 1, 5, 1, 6, it's always that. So 1, 4, what's the middle number? 6, 4, and 1. Then starting from the left, I'm going to take the x and raise it to the fourth, then to the third, then to the second, and then to the first. And then starting from the right, I'm going to take the h, raise it to the fourth, raise it to the third, raise it to the second, and raise it to the first. And that all that is the x plus h to the fourth. We still have all of this left to do, right? So we're now going to distribute the 2 into the parentheses, and we get plus 2x plus 2h, and then what's next?
Minus 3s to the 4.
Yeah, we have to, not plus, we have to distribute it to everything. So everything changes signs. And so we get a minus 3x to the fourth and also a minus 2x. And you'll catch those sign errors all over h when things don't cancel as they should. So easy to make an error. I'll do it all the time. But you catch yourself by using these little checks that you should know how it works out. Don't force the check, correct the errors. All right, so then let's distribute our 3. So we've got equals the limit as h approaches 0. That's real sloppy. So we've got 3x to the fourth. You're going to run out of room. Plus 12 x cubed h plus 18 x squared h squared plus 12 x h to the third plus 3 h to the fourth plus the 2x plus the 2h minus the 3x to the fourth and minus the 2x all over h. Whew. Now you know why your algebra needs to be strong. All right, so now we're looking to cancel. Everything without an h has to cancel, or you did something wrong. So let's start with our 3x to the fourth. Don't we have a negative 3x to the fourth? The next term that doesn't have an h, there's an h, there's an h, there's an h, there's an h. Oops, the 2x. Notice how we have a minus 2x. Those are the only two things that cancel. So we've got our 2x canceling with our negative 2x. The rest of these are all left over. So I'd highlight these if I were you. So those are all left over. What do they all have in common? In h. So the limit as h approaches 0 of h times 12x cubed plus 18x squared h, I'm factoring out that h, plus 12xh squared plus 3h to the third plus 2. All of that is divided by h. Whew. So cancel out your h. Then if I were you in the next step, I would go ahead and plug in a 0 for any term that has an h in it, which should then cancel out those terms. So you should really only have a 2x cubed with or 12x cubed with a 2 left over. And so our almost final step is the limit as h approaches 0 of 12x cubed plus 18 times, oops, not times yet, 18x squared times 0 plus 12x times 0 squared plus 3 times 0 cubed plus 2. So that leaves us with f prime of x is equal to 12x cubed plus 2. So that is the general equation for the slope at any point on that line. General equation for slope. Now, questions on that? There's a lot. That's about as complicated as it's going to get, with the exception of fractions, which is D below this, but you're not going to do that yet. So wait till everybody has it written down. Except for Arnold, because you probably just started. Okay, good. All right, so any questions on that? Are you good? Did that make a little bit more sense the second time around? Using some prior knowledge with using Pascal's triangle to raise that binomial to the 4th power. So then you're going to do on your own, and I'll quietly do it up here, you're going to find the derivative, and that's that new notation, that's that Leibniz notation. You're going to find the derivative of the function. So this is an easy function. So I'll get you started. So you are going to find the derivative as the limit of the limit as h approaches 0 of f of x plus h minus f of x all over h. So apply those. if I asked you to find a derivative using limits like this, and you leave off the limits and you leave off the over h, because I'm grading you on your work, yeah, I will mark you off for that. Mostly because I need to see that you can do those steps, because as the problems become more difficult in calculus and you have to do this, you can't be skipping those steps. Because it'll kill you. Has anybody not reached the 12x? We good? You will skip them steps. You're doing that right, Isaac. Thank you. I appreciate that.
Can you go back to example B?
Yes. So back to example B. What's your question?
I just wasn't, I don't know.
Oh, okay.
Say like the last part.
So nobody has questions on C while Jason's catching up? Good? Okay. So then let's look at D. D's innocent enough looking, except for the fact we've got this fraction. So this fraction is going to create some issues here, but we're still going to find, this is, again, Newton's notation. It just means find the derivative of. So we're going to take y prime, which means the derivative of, is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Same start we've had all along. Equals the limits as h approaches 0 of, now take your function, which is 1 over, and replace the x with x plus h. So that's f of x plus h right there. But then we have minus 1 over x. All of that is over h. Anybody not know where I got that? And I want us all to be in the same spot before I move on. Okay, so in order to combine these two terms in the numerator as one term and one fraction, what do I have to have? Common denominators. So you have to find the LCD. What's the LCD here? The common answer is x plus h, but that is not the LCD. I cannot change x into x plus h by multiplication, right? This is fully factored denominator, so that's a factor. The whole thing, x plus h, is a factor. This is a fully factored denominator. That's a factor. Those are two separate factors. Yep, so your LCD is x times x plus h. That's your LCD. So what's the first fraction here missing so that it looks like that LCD in x? So I've got to multiply both the denominator and the numerator by that x. What's the second fraction missing? X plus h. So again, top and bottom, get that x plus h multiplied. So then I'm going to go ahead and start simplifying. So now that they have the same denominator, I can just combine the numerators. So this first one is x, but I've got to write it as the limit as h approaches 0. Oh, that was horrible. As h approaches 0 of x, and then I'm going to distribute this negative into the x and into the h. So it's not just minus x, it's minus x minus h. So I get minus x and minus h because I'm subtracting the whole numerator, x plus h. And then all of that is over the LCD of x times x plus h. And then rather than put all of this over h, when we have a fraction in a fraction, what do we do with that denominator? You multiply it by what? Actually, by the reciprocal. What is the reciprocal of h? 1 over h. I had a lot of discussion in the last class about that. So this right here, we are multiplying, so multiply by the reciprocal of the denominator. The discussion I had in the last class was they felt that this was 1 over h, and so the reciprocal should be h. Think about it. This is division by h. You cannot multiply by h and have the same answer. You cannot divide by h and multiply by h and get the same exact result unless h is 1. Right? Would you say that dividing by 2 and multiplying by 2 give you the same answer? Take 6 for instance. What's 6 divided by 2? 3. What's 6 times 2? 12. They don't give you the same answer. But if I take 6 and divide it by 2, which is 3, what's 6 times the reciprocal of 2? What's the reciprocal of 2? 1/2. So what's 6 times 1/2? Now that gives you the same answer. So this does have to become 1 over h. And the nice thing is the x minus x cancels. So we have here the limits as h approaches 0 of a negative h, and I'm putting an extra step in here just so you can see what's going to happen here next, 1 over h. So don't the h's cancel but not the negative? And so for my nearly final step, I'm going to replace any h with the 0. So I really have a negative 1 in the numerator all over x times x plus 0. And that means that y prime is equal to what? Negative 1 over x squared. So that is the general equation form for the slope of any tangent line to that curve. So you've now just found 4 different derivatives. You'll really be happy when you see the shortcut. But not today. Yes?
When do we use that Pascal triangle thing?
We use a Pascal's triangle if we have to raise a binomial to anything other than the second power, because you should know how to square it, right? But if you raise it to the third, fourth, fifth, sixth power, you're going to use that Pascal's triangle method. All right, any other questions before we move to the next page? Courtney?
I actually have a question about last night's homework.
Can we do that later? Not
Oh,
today.
no, it's not a problem. It's just I tried using your, like,
Okay, so let's talk about that later, because that's not going to have any bearing on this, is it?
well, yeah, I just couldn't do the homework.
Right, but that's not going to have any bearing on this lesson today, right? So you can ask me that when I'm done, okay? So let's look at the next page. All right, so example 5, we're going to use derivatives to find these 4 things. So, well, first we're going to find the derivative, and then using that derivative, we're going to find the slope, the actual slope at a certain point, and we're going to find the equation of the tangent line at that particular point, and we're going to find the point where the tangent line is horizontal. So we're going to do 3 different things using our derivatives. So I'm going to make this as big as possible. We are going to have to correct this ordered pair here. So this ordered pair needs to be 4, 40. So this should read not a 3, but it should read a 40. So correct that, please. It'll be important later. All right, so the first thing I want you to do is find the derivative. So step 1, find your derivative. So I'm just going to quietly do it up here, and then you can do that on your own. Oops. So as you finish, look up here, see if you and I agree.
Your worship is just as well.
I know it's a pain when you write all that. You won't have to do it full time. That means you really have years. Do it. The expose part. I squared the expose, not the one x squared plus 2x plus h squared. That's what I did on the left hand. So all of this, you should get used to doing in your head, that this got replaced with all of that.
When it goes to the.
Oh, here?
To the other
I
side.
factored an h out. Is that what you're looking at?
Yeah,
So I could
but
take
what
an
is
h out of
the-
here, and so it becomes a 6x.
Yeah, but where did the square root of the 3h go?
This one,
Yeah.
I took an h out of there, so I just get a 3h,
Oh,
because there's an
gotcha.
h out in front,
Yeah,
right?
yeah.
Anybody else not clear as to where some of that came from? And so that way your h's can cancel. And then you're left with just one h term. And so when you plug in that 0 into the h term, you're just left with a 6x minus 2. So what is that 6x minus 2? What does this represent? This is slope. That's your general equation for slope. And you might want to note that on here. This is the slope. of any line tangent to the function. So that's number one. Then we're going to find number two, the slope at a particular point, and the particular point is 440. If you plug 4 into 3x squared minus 2x, you get 40. And so I'm going to move this over and use this other side here. So 2 we're going to use our general form. M equals 6x minus 2 at the point 440. So remember that this is your x value and this is your y value. So you'll like this one. This one's easy. And just like yesterday, remember yesterday when we were trying to use limits to approach a particular number, and if I gave you the point, we only looked at the x value? Well, look at your equation right here. We don't have any y values in the equation. We only have an x value. All I care about is the x value. And so when I find slope, that's 6 times that x value of 4 for my x minus 2. And so slope is equal to 22. So the slope of the line tangent to the point 440 is 22. And then the third question is asking you to find the equation of the tangent line at that point. So at that particular point, I want to find the equation of the tangent line. So here's step 3 is a little bit more involved. Do you have a question, Valeria? Are you okay? Okay. So for step 3, you're going to use point slope form. To find the equation. And your point slope form is y minus y sub 1 equals m times x minus x sub 1. So we're subbing in for the y sub 1 and the x sub 1 and the m. Here's your m, and here's your x sub 1 and y sub 1 up here. Just plug, just like algebra 1, 2. So we have y minus and x minus. And I'm plugging in for y the 40, for the m the 22, and for the x the 4. Do the math. So you get y minus 40 equals, distribute the 22, 22x minus 88. Then add 40. Y is equal to 22x minus 48. So that's the equation of that tangent line to the point 440, and as you can see, doesn't it have a slope of 22? Yep. And so the last thing that we're going to find is the point where the tangent line is horizontal. Let's just look at a parabola, for instance. This happens to be the equation of a parabola, but if we were looking at a parabola, let's put, so here's my parabola over here. Let's just say, oh, actually this is a parabola opening up, isn't it? Let's be a little bit more accurate. So if this is the equation of my parabola, where would my tangent line be to make that slope horizontal? What is a horizontal slope anyway? 0. Where is a horizontal slope always on a curve? Yep, right there at the vertex, and we talked about that yesterday. So we're looking for the point at which this occurs. So we're looking for this point right here. We want to know what that ordered pair is right there. Well, I know my general equation for my slope is 6x minus 2, and I know that my slope is 0. So can't I use this equation here? I can plug in 0 for m because the slope of a horizontal line is 0, right? And then can't I solve that equation for x, and that'll give me the x value of my ordered pair? That's what we're going to do. So for part 4, we're going to take that general equation, m equals 6x minus 2. We're going to replace the slope with 0. Horizontal lines have a 0 slope. And we're going to solve for x. So add your 2. And then be really careful. When you divide both sides by 6, x is not 3. What is it? It's 1/3. That's only the x value of our ordered pair. This is an ordered pair that is on the function. So where do I want to plug that x in order to find my y? Sam, what are you plugging into?
Y equals 2x minus 28.
No, because this is the equation of the line that's tangent, so it's like some line that's over here somewhere. We want to plug it into this function right here, which is, it's missing over here, but it's the 3x squared minus 2x, right? So we're going to take f of x, and our x that we're plugging in is this 1/3. So our f of x is equal to 3x squared minus 2x. So wherever I see an x, I'm going to plug in that 1/3. Remember, f of x is the same as y. So I get 3 over 1 times 1 over 9 minus 2 over 3. Doesn't the 3 cancel into the 9 3 times? So I end up with 1 over 3 minus 2 over 3. What's 1/3 minus 2/3? We add the opposite, it makes it a whole lot easier. What's 1/3 plus a negative 2/3? What's 1 plus negative 2? Negative 1. And so our f of x is equal to negative 1/3. And so our ordered pair, our x value is 1/3, our y value is negative 1/3. And that's the answer that we're looking for there. Almost done. So any questions on that? So we just use the derivative to find just additional things. So if I were you, I would put on this question, above this question, study, study, study. It's a process. You need to learn to study that process. All right, so the last question, you can do this all on your own. You're going to find the formula for slope, so it's just like question 1, or part 1 above. You're going to find the formula for slope by finding the derivative. And then you're going to use that formula for slope. You're going to find the actual slope at points -1, 2, and 2, 5. So you're basically doing step 1 and step 2 from above. So you're going to do, can I move this? Anybody not want me to move it? Okay. So for example 6, and I'm not going to say anything, I'm just going to do it, but you're going to quietly do steps 1 and step 2 from above. So start off with your derivative. So you're doing this by yourself. Make sure that you're getting the correct answer, not just packing up. So this last problem is much simpler than the problem above it. You're just doing parts 1 and 2 above here, and you're finding the slope. So the slope of the tangent line at -1, 2 was -2, and the slope at the 0.25, the slope of that tangent line is 4. All right, Courtney.